The certainty equivalent value equal to 3,869.962. So the risk premium is 130.038. Let me double check.
Cầm này. Điên này.
Yeah, I think the number a little bit different, but I think it's due to the rounding. Do you guys got the same result? The other people, do you get the same result? In this case, I think, yeah. Let's see. Okay, one of you guys get the civil result is 126.166. Okay, let me. Because in calculation, just a little bit makes it a big difference. So it's the current value is 4,000, right? 50% winning 1,000, 50% losing 1,000. So EW equal to this number. EEW equal to, so expected utility of the gamble is 50% of 5,000, 50% logarithm of 3,000. So it is I think it's 8.262. And the certainty equivalent value should be e to the power of u and equal to e to the power of 8.362. Yeah, it should be this number. So the risk premium should be 4,000 minus yeah, I think one of you guys got the correct result. So it's just only a little bit different. I think it's not because of you use the wrong methods, but I think when you do the routing, it makes a difference. So if in this case the risk premium is 126, approximately 126, so it's higher than 125. So when you buy the insurance or when you take the gamble, the risk premium you can pay you are willing to pay up to the risk premium to avoid the risk of the gamble. So in this case, yeah, you will buy the insurer. Okay. So this is quite. I think this example is quite easy to start with. Now, let's move to. Do you have any question about this exercise? I think it's quite similar to the example I already gave you. So, exercise, exercise two, exercise two. In the exercise two, you have estimated the following probability of EPS of company A and B. The probability of company is 0.1, 0.2, 0.4, 0.2, and 0.1. And with the respective EPS, now you need to part A calculate the mean and the variance of EPS for each company. Part B explain how some investors might choose A and others might choose B if the preferences are based on mean and variance. Part C compare A and B using the second order stochastic dominant criterion. So in order to compare, in order to rank the assets or to rank the investment opportunities, you can use two methods as I introduced you in the lecture. Two methods. First is the first order or the second order stochastic dominant criterion, but it is quite complicated. And the second method, which is more popular, is the mean variance method. So in part A, part B, you will use the mean and the variance method to compare A and B. And in part C, you will compare A and B using the second order stochastic dominance. You still remember how to calculate mean and variance? I wish that I can were able to share with you the file. Because I cannot share with you the file. You can do it on the Excel file if it is easier for you, or you can do it by using the calculator. So let's do the mean first. So the mean of EPS for company A equal to from A. Let's do from A first. It should be 0.1 times 0 plus 0.2 times 0.5 plus 0.4 times 1 0.2 times 2 0.1 times 3, right? So the mean can be calculated by multiply the property to the EPS to the outcome, right? And the variance. How much is the EPS of from A? How much is the EPS of from A? Should be 0.2. Okay. That's 0.1 times 1.2 square plus 0.2 times 0.5 minus 1.2 square plus 0.4 times 1 minus 1.2 square plus 0.2 times 2 minus 1.2 square plus 0.1 times 2 minus 1.2 square. Yes. Show me how much you get for the variance. Oh boy, 71. Oh boy, 71. Yeah? Oh boy, 71. Yeah, that's the correct. 0.71. So can you do it for B? How much E? I know it's difficult for me to write symbol, mathematics symbol here. How much is EB? EB equal to? How much is EB in variance B? And how much is the mean of EPS for company B? $1.55. I got 1.50. Anyone got 1.55? Yeah, 150. It should be 150. Okay, 1.50. And the variance is how much is the variance? Yep. 2.088. Yes. 2.088. That correct? Okay, so we are done with part A. Do you need me to calculate from B? It's similar to from A, so I will skip it. Part B. Explain how some investor might choose A and other might choose B if the preferences are based on mean and variance. If the preferences are based on the mean and variance, so a risk-averse investor will prefer A or B. A risk-averse investor will prefer A, right? Lower variance, lower risk. While a less risk-averse investor will prefer B, because B have a higher return. Um, Actually, there is a feature showing the indifferent curve for a risk-averse investor and a less risk-averse investor. But I show you later when we study offline. Now, I show you later this feature because it's quite difficult to show you here. Now, let's move to part C. Part C compare A and B using the second order stochastic dominant criterion. You can look at the exercise, look at the example in slide 45. Look at the example in slide 45 to see how to calculate the second order stochastic dominant. Then I will show you step by step. But first look at the example in slide 45. In slide 45, you have the first column is a different value of EPS. Okay. Then the next column is the probability of EPS. For firm B, probability of EPS. For firm A, then FB and GA is the cumulative probability distribution. And you do F minus G and the accumulated F minus G. And you see whether it's applied, whether the second order stochastic dominant applied. What is the second order stochastic dominant? You can go back to slide 36. X is 1 higher than Y if GY minus FX is greater or equal to 0. Now I think we can use micro Excel to do the exercise. It should be quicker. It could be quicker. Now if you have micro Excel, you can open it. I will do it and then I will send you this file. Okay, now I show you step by step. So this is my PowerPoint. So in the first column, you have a different value of EPS. So the first column is EPS, and different value of EPS. You see, EPS can range from minus 0.5 to 4. I think the highest value of EPS in this case is 4. Yes, from minus 0.5 to 4 and the interval is 0.25, right? The interval 0.45, 25. Let me show you. So the first column is EPS, then okay, the value, you list all the value of the EPS, so it's minus 0.5, then minus 0.25, then 0, right? You got what I'm doing. Okay? If you don't understand, just stop me anytime, okay? My 25, 0, 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, 2, 2.25, 2.5, 2.75, 3, 3.25, 3.5, 3.75, 4, 4, yeah, 4 is the height value, right? You see, in the question, the lowest value of EPS is minus 0.5, and the highest value is 4. So you, in the first column, you list all the possible value, possible outcome of EPS, and in the second column is the property of EPS for from A, and the next column is the property of EPS for from B. Property of EPS for from A, property of EPS for from B. Okay, let's see. For from A, the EPS can be 0, 0.5, 1, 2, and 3. Okay, so you will fill in. You fill in the gap. So EPS equals 0. The property is 0.1. 0.1. EPS equals to 0.5. Property is 0.2. 0.2. EPS equal to 1. Property is 1. Sorry, property is 0.4. 0.4. EPS equal to 2. Property is 0.2. EPS equal to 3. Property is 0.1. Okay. In the other cell, okay, in the other cell, just fill in 0. Fill in is 0 in the other cell. Okay. Don't worry if you don't know how to do it, because I'm gonna send you the file. Other cell you fill in 0, and you do it for from B. For from B, if the EPS is minus 0.5, the property is 0.1. If the EPS is minus 0.25, property is 0.2. If the EPS equal to 1.5, property is probability is 0.4. If EPS equal 3, probability is 0.2. If EPS equal 4, probability is 0.1. Okay. For the other cell, you fill in 0. Yeah. Yes. Then you got SA and GB. So let me send you this file first. Let me see whether I can copy and paste it. Ah, yes, I can do it here. Yeah. You see it? understand how I do it? Okay, so for the first column, it owns the value of EPS. The next column is the probability of EPS for firm A, and next column is probability of EPS for firm B. Then you calculate the cumulative probability distribution FA. FA for firm A. Zero. It should be 0, 0, 0.1, 0.1, 0.3, 0.3, 0.7, 0.7, 0.7, 0.7, 0.9, 0.9, 0.9, 0.9, 1, 1, 1, 1, 1. Got this? And GB. What is GB? GB should be 0.1 and then 0.3, and then we do 0.3 for all next column, 0.3, and then 0.7, then we do 0.7 for the next, 0.9, 0.9, 0.9, and 1. Okay. Then you take the difference between F and G. I showed you the next column for GB. Let me show you. Do you understand what I'm doing? Yeah. Can you see? If you move to the right, you see probability A and FA. Okay, probability would be 0 in the first line, 0 first line, and then 0.1. Cột FA và cột GB là chúng ta đang làm gì nhỉ? Cộng dồn xác suất. Cộng dồn xác suất này nó sẽ là 0 này, cộng 0 này, bằng 0 này. Dòng thứ hai nhé, dòng thứ ba là 0,1 cộng với 0 thì sẽ bằng 0,1 này. Dòng thứ tư là gì nhỉ? Vẫn là sẽ là 0,1 này. Dòng thứ 5 sẽ là 0,1 cộng 0,2 bằng 0,3. Tương tự như thế chúng ta cộng dồn xác suất. Tiếp theo next we take the difference between F and G. F and G. You can do it easily with Excel. F minus G. And then it is you do the accumulated. You take the accumulated difference between F and G. So it should be minus 0.1, minus 0.2, minus 0.6, minus 0.8, minus 0.8, minus 0.8, then it's minus 0.4. Then it's equal to 0. Okay. It's 0, 0, 0.2, 0.4, 0.4, sorry, 0.2, 0.4, 0.6, 0.8, 0.9, 1, 1.1, 1.2, and 1.2. Yes, So I complete on table. It should be bear with me 1 second, I'm trying to find a symbol. Seems to me no symbol like it. Yeah, I already got it. Let me paste it here so that you can see. Oh, I have to soften my message. So I delete the first 2 columns, because I already sent it to you. I have to say soften my message, otherwise I cannot send it. Yep. Can you see it? So in the last column, we can look at the last column to answer the question of the second order stochastic dominant. Okay. So the question of part C is compare A and B using the second order stochastic dominance criterion.